Hi everyone, today we have a question based on rotational dynamics, and in this question we have a rotating disk rotating at an angular speed of omega naught, which is placed at the corner of a wall where the only point of contacts are the wall and the ground itself, and we are to find the number of rotations it will take for the disk to stop rotating. Of course, we can't neglect friction because friction is the only force for which torque will be produced and will provide the necessary angular acceleration in order to bring the angular velocity down to zero, right? Analyzing the direction of forces, we have frictional force, let us say F1, acting at this point of contact between the ground and the disk, and F2 acting upwards at the point of contact of the wall and the disk, right? For this F1 there has to be some corresponding N1, and for this F2 will have some N2 normal reaction. Of course the weight will be acting downwards, mg, right? So for now we know that the system is in translational equilibrium, so we'll have two equations if we conserve the forces in vertical and the horizontal directions, right? So for the force conservation in the vertical direction, we have N1 plus F2 is equals to mg, right? And in the horizontal direction we have N2 is equals to F1. Let us call the coefficient of friction to be mu at both of the surfaces. So we'll have F1 as mu times N1 and F2 as mu times N2, right? Now, in order to find the number of rotations, we'll have to find the net angular displacement, which is theta, and that can be found by finding the value for alpha and using the equations of motion. Alpha can be found by finding the torque, right? Because we know that there is a torque and angular accelerations equivalence, tau is equal to I alpha, so that can be done. Now in order to find torque, we'll have to find the net force. So our problem is now to find the net force. Now we had two equations, let us call this as 1 and this as 2. We have two variables N1 and N2, right? We'll be solving these two equations 1 and 2 and we'll be getting the value for N1, and also we'll be plugging in the values for F1 and F2 right over here and there, right? So we'll have the value for N1 by solving these two equations and these two as well. Mg over 1 plus mu squared and N2 as mu times mg over 1 plus mu squared, right? So we have N1 and N2, right? Now we'll be finding the value for net torque. So we have R times F1 plus F2. So we have a plus because F1 and F2 act in the same direction, in the same sense, and are couple forces, so they will have the direction of the torque same about the center of mass of the disk, right? So we have this as R times mu times N1 plus M2, that is mg over 1 plus mu square plus mu times mg over 1 plus mu squared, right? So for the final value of the net torque, we have R times mu times mg times 1 plus mu over 1 plus mu squared, right? So we have the value of the net torque and angular accelerations equivalence in order to find the value for alpha, and we know that the moment of inertia of the disk is m r square by 2. So we'll have the value for alpha as 2 times mu g over r times 1 plus mu by 1 plus mu squared. Third equation of motion, which was 2as is equals to v squared minus u squared. The rotatory analog for this equation is 2 alpha theta is equals to omega final squared minus omega initial squared, right? We know that the final angular speed is 0 because we have to find the theta for which the final angular speed is 0, and we have the value of alpha, and we know that the omega initial is just omega naught, right? And also conventionally, if we see, so alpha has to be some negative value because it is a retarding angular acceleration. So we'll have minus 2 alpha theta is equals to minus omega naught squared, right? Minus minus cancels away. We'll be plugging in the value for alpha from here. So we'll have the answer, the final answer in terms of theta will be omega naught squared times r into 1 plus mu square by 4 mu g times 1 plus mu. Now in order to find the number of turns, we have 2 pi times the number of turns as theta, right? For the number of turns, we have theta over 2 pi. Hence the number of turns are omega naught squared times r 1 plus mu square by 8 pi mu g times 1 plus mu, right?